combination is an arrangement of objects without regard to the order. So when it comes to combination, the order of the objects or the selected objects doesn't matter. So the formula to get the combination of objects, we have NCR is equal to n factorial all over n minus r factorial times r factorial. So if you can still remember, there are a lot of types of permutation. But when it comes to combination, we only have one formula, which is, again, we use the symbol NCR, where again, n is the total number of objects and r is the total number of selected objects. So that is combination. So now, what's the difference between permutation and combination? Again, they are both number of ways of selecting r number of items out of n number of items. Again, they can both help us determine the total number of possible outcomes. But what's the difference between the two? Again, when it comes to permutation, the order is important, or the order of the arrangement of objects is important. The keywords when it comes to permutation are arrange, order, formed, and many other keywords. Combination, on the other hand, is when it comes to combination, the order is not important. Again, when it comes to combination, the order does not matter. And the keywords when it comes to combination are group, sample, selection, and many other keywords. So those are the differences between permutation and combination. Now let's have example number 1 so we can apply the concept of combination. For example, we have, as the party coordinator, you prepared 10 games for a children's party. If there is just enough time to play 4 games, in how many ways can you choose the 4 games to play? Now, which is the keyword in this problem so that you can tell that it is combination? The word choose. So, it did not tell us that we have to arrange or choose which one comes first, second, third, or fourth. It just asked us to choose 4 games to play. It means that the problem is asking us to choose a combination of 4 games to play out of 10. Therefore, the value of n is equal to 10 because that's the total number of games. And the value of r is equal to 4 because again, we have to select 4 games. We can now apply the formula for combination, which is again NCR is equal to n factorial all over quantity n minus r factorial times r factorial. So let's just plug in the values. We have 10C4 is equal to 10 factorial all over quantity 10 minus 4 factorial times 4 factorial. So 10 factorial is equal to 3,628,800. All over, we have 10 minus 4, that is 6. 6 factorial is 720 times 4 factorial is 24. Therefore, we have 3,628,800 divided by 720 times 24. And that is equal to 210. Therefore, we have 210 ways to choose the 4 games that we can play out of the total of 10 games. So that is how you apply combination in problem solving. Next, let's have another example. For example, we have Sebastian's ice cream shop offers 15 flavors of ice cream and 10 toppings. The question is, how many combinations can be made from choosing 3 flavors of ice cream and 5 toppings. Now, if we are going to observe or analyze our problem, we can see that we have two categories. The first category is the ice cream flavor, and the second category is the toppings. For the first category, our n sub 1, or let's consider it as n sub 1. So our n for the first category is equal to 15 because we have a total of 15 flavors of ice cream. And out of the 15 flavors of ice cream, we are going to choose 3 flavors. Therefore, our R is equal to 3. Again, for the first category. For the second category, which is the toppings, our N is equal to 10 because we have 10 toppings. And out of the 10 toppings, we are going to choose 5. Therefore, the value of R is equal to 5. That's for our second category. Now, how can we use the formula for combination? Now, just like what we did in fundamental counting principle, we just have to multiply each number of possible outcomes for each category. So let's first get our number of possible outcomes for the first category by using the formula. So let's get 15C3 times 10C5. That's for the second category. So for the first category, we have 15 factorial all over 15 minus 3 factorial times 3 factorial. And for the second category, we have 10 factorial all over quantity 10 minus 5 factorial times 5 factorial. For the first category, we have 455 possible outcomes. Times, for the second category, we have 252 possible outcomes. So 15C3 is equal to 455 and 10C5 is equal to 252. Now again, by just applying the fundamental counting principle, we just have to multiply so we can find the total possible outcomes. So 455 times 252, that is equal to 114,660. Therefore, there are 114,660 possible combinations.